All right, so this is the continuation of 5.2, which is trig functions. So we're going to go through a little bit of what we talked about yesterday, and then we're going to jump into the continuation. First of all, this slide has almost all the, well, we'll add some stuff, but has a lot of information that you need, okay? In addition to this, we reviewed SOHCAHTOA, sine is opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. We reviewed the Pythagorean theorem, a squared plus b squared equals c squared, can be used to find the third side of a right triangle. We reviewed the common triples, 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25, and 8, 15, 17. These are not the only triples that exist, but these are the common ones. And then we went through the identities on this one. The other page had the reciprocal identities. No, I mean, you could get ones that aren't triples. You'll keep it as a square root. Yeah. So the reciprocal identities say that sine is 1 over cosecant, and the reverse, cosecant is 1 over sine. Cosine is 1 over secant, and secant is 1 over cosine. Tangent is 1 over cotangent, and cotangent is 1 over tangent. So those were the reciprocal identities. Then we went into, on the right, the quotient identities. Tangent is sine over cosine, and cotangent is cosine over sine. Then we went to the Pythagorean identities. Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant squared. So after the notes today, I'll teach you a trick on how to remember those. And then the top is the solution intervals. So this is the values that these can be. So the tangent, well, let's start with sine and cosine. The sine and cosine of any angle has to fall between -1 and +1. So it can't be smaller than -1 and it can't be bigger than +1. Cosecant and secant are the reverse. They have to be less than -1 or greater than 1. And then tangent can literally be tan or cotangent, can be any of them. So in the homework, there was questions that said, like, is it possible or impossible for the cosine of theta to be 1.12, let's say? And that would be impossible because cosine can't be bigger than 1. If it said tangent of theta equals 1.12, that's possible. If it said cotangent, same. If it said secant or cosecant, also would have been the same. But cosine or sine, for that matter, that would have been impossible if it's bigger than 1 or less than -1. Yeah. Sure. So as you complete the rest of the homework tonight, there were questions that asked for that, and that's all it's looking for.
So tangent and cot can be more than 1?
Which one? Tangent and cosine, tangent and cotangent have no restriction. It could be anything at all. Positive, negative, 0, anything. That can only be less than -1 or bigger than +1. So it can't be in between -1 and +1. Okay, and then this was the next example. So we did 5, but pay attention to directions because it says use the Pythagorean identities to find the following. So this means we're going to use either sine squared plus cosine squared equals 1. Yeah. And then tan squared plus 1 equals secant squared. And then 1 plus cotangent squared equals cosecant squared. So you're using from that bank. If it just said solve, I would have approached this in a completely different way, and that's like the next example, and it's way easier. The fact that it tells you Pythagorean identities is the one that forces you to use one of these 3 things. So when you look at number 6, it says find cosecant if cotangent of theta is -1/2 and theta is in the 4th quadrant. So the only one of our three that has cotangent, which is the information that you're given, is that bottom one. 1 plus cotangent squared equals cosecant squared. And really it's like cotangent squared of theta and cosecant squared of theta, but I just don't, to remember it, I get lazy. I leave that stuff out. So if cotangent squared is negative a half, I'd get 1 plus negative 1/2 squared equals cosecant squared. And then I would square the negative 1/2. I'd get 1 plus 1/4 equals cosecant squared. And it would be so cosecant squared theta. And then this is 4/4 plus 1/4, so 5/4. That's cosecant squared. And then to solve for cosecant, I'm going to square root. And it would be plus or minus, but we're going to pick one in just a moment when we look at what quadrant it's in. So I'd get the cosecant of theta equals the square root of 5 over the square root of 4, which is 2. And then I have to determine if it's positive or negative. And that's where the quadrant comes into play. With me so far? Yeah? Well, we're going to look at it now. So quadrant 4 means I go forward, so it's a positive x, and down, so it's a negative y. My cosecant is the reciprocal of what? Nope. We are, but we need to know what sign to use. So because my x is positive, my y is negative, right? If this was cosecant, then sine would be the reciprocal, which would be 2 over root 5. And on my triangle, that would be opposite, which would be the 2, and the root 5 would be the hypotenuse. That 2 has to be negative because the y or opposite side is negative. So now I know to pick the negative version of this, which would be negative root 5 over 2.
But for the problem above, they're both negative.
Once I flip it, I get sine, right? Reciprocal is sine. And so 2 over root 5 means the opposite side because sine is opposite hypotenuse. So opposite the theta would be the 2, and the hypotenuse would be the root 5. But the 2 has to be negative because the y is moving down. So that's how I know to pick it as a negative root 5 over 2. So we said tan of 4/3, right? If it's in the third quadrant, that means we're moving left and we're moving down, which means it would be, so this is opposite and this is adjacent. Opposite would be 4, adjacent would be 3, but because they're left and down, they both have to be negative. And then your hypotenuse is still 5 and it's positive, so it makes the cosine negative. Does that make sense? Okay. Questions on that? So again, pay attention to directions. It's going to happen on the quiz too. If it says use Pythagorean identities, you have to use one of those 3 to find the value. Then you use the quadrant to figure out if it's positive or negative. In an example like this, it says find the value of the 6 trig functions of an angle of standard position running through 4, 0. So I'm not going to recommend we do this every time from here on out, but if you want to give yourself the visual, negative 4, 0 would be to the left like that. Up to this point, if you had any other combination of numbers there, if it was like negative 4, 1, I would go up 1 and I would draw my triangle and I would make theta in the corner. But if it's on your quadrant angles or if it's on the axis, you obviously can't make a triangle with this. There's nowhere to go up from here, okay? So there's no way to make a triangle from this. So this is where you revert back to on the very first slide. It said sine was y over r, cosine is x over r, and tangent is y over x. Also on that sign, told you r is the square root of x squared plus y squared. So if you can draw a triangle, you don't have to do all this. Because you can draw the triangle, use the Pythagorean theorem, which is really what this is. This is just the Pythagorean theorem in a different way. This one. And you could find it from there. But if it doesn't fall inside the quadrant, if it's on an axis, you obviously can't make a triangle. There's only one dimension here. I can't make a triangle in any other direction. So the first thing I'm going to do is find out what the radius is, which I could do that square root of x squared plus y squared. Or what would a radius be if I went to the left? 4. 4. That's it. So my radius is 4. If I went up 4, right 4, down 4, or left 4, the radius would still be 4, okay? I'd get the same answer by doing the square root of negative 4 squared plus 0 squared, square root of 16, which is 4. So now I go, the sine is the y coordinate of my coordinate point, which is 0, over 4. And 0 over 4 is, over 4 is what? 0. And then I go cosine, and that's the x coordinate over my radius, so negative 4 over 4, which is negative 1. And then I do tangent, which is y over x, 0 over negative 4, which is 0. And it wants all 6. So then I do the cosecant, which is the reciprocal of 0. What's the reciprocal of 0? Undefined. And then I do secant, the reciprocal of negative 1. What's the reciprocal of negative 1? Negative 1. And then I do cotangent, reciprocal of 0, which is undefined. Questions on those? So when we get to the homework, I'll say how do I spot the difference? How do I know what to do when? I'll kind of pull it up so that I can help you with that a little bit. But the difference with this one is that the coordinate point is on the axis. So if there's a 0 in either spot, you're going to do it this way. All right, 8 and 9 are both based on quadrant angles. So notice the angles in these statements are 180, 360, okay? If they were 90, 270, anything like that, these are all based on your quadrant angles. So you want to make sure you know those as well. We're going to build on this eventually. But for right now, I want to know 0, 90 degrees, 180 degrees, 270, and double back around to 360. Those are your quadrant angles. The coordinate points at these are 1, 0 because you moved to the right one, 0, 1 because you went up 1, negative 1, 0 because you went left 1, and 0, negative 1 because you went down 1. It's imperative that you know your quadrant angles, okay? Because from here, we're going to use those values to plug in here. So secant at 180 means I'm going to go to the 180. Secant is the reciprocal of what? Cosine. So what's the cosine at 180? Remember, sine is y, cosine is x, tan is y over x. So the cosine at 180 is negative 1, right? What's the reciprocal of negative 1? Huh? Still negative 1, right? Just flip it. It's still negative 1. So this becomes 3 times negative 1 minus 5.
So all of these will always use that graph.
Yep. And then I go to the 360. 360 is on the right where 0 is. And the tangent would be the y over the x. So what would be the tangent there? 0. And I'd get negative 3 minus 0, which is negative 3. We're going to try another one. Yeah. Because so when you go to 360, you do which is 1, 0. You do the y over the x. 0 divided by 1 is 0. All right, we're going to do it again. So for 9, we just did the tangent of 360. If we didn't just do it, we would have gone to where 360 is. We would have put the 0 over the 1 and that 0. Plus 4 times, now I want the sine at 180. Which coordinate point do I grab if it's sine? The y. What's the y at 180? 0. Plus 2 times the cosine squared of 180, which means I'm going to find the cosine at 180 and then square it. So what's the cosine at 180? -1, and then I square it. And I'd get 0 plus 0 plus 2 times 1, which is 2. Yeah, I mean, if it was any other value, it would change it. This one, it just changes the sign. But yeah, you square it after, so you get the cosine and then you square it. So if you look at that first page, if you started yesterday, hopefully you did these, okay? These are the ones where you would literally just set up a triangle. So for number 3, if I'm going left 3 and up 4, I would make a triangle in my second quadrant. This would make -3. This would be +4. I'd find my missing side, and I'd find all 6 trig functions. So that's your SOHCAHTOA. If it's a triple, which that one is, you could fill it in. If not, you're going to use the Pythagorean theorem. 5 and 9 are different because they are quadrant angles. They are going to fall on the axis. So whether it's 0, 2, or -2, 0, they both fall on the axis. So you have to find what your radius is. You could literally count. And then you have to do the sine is the y over the r, the cosine is the x over the r, and the tan is the y over the x. That's 5 and 9 are like that. When you go to 23, 25, and 27, those are the ones just like we just did. So you're going to use your quadrant angles. 45, 47, and 49, you're using the reciprocal identities. So it's so important you read your directions here. When you look at 57 and 59, you're using your quadrants to satisfy the given conditions. So think when you're in the top right quadrant, or quadrant 1, your x is positive and your y is positive. In quadrant 2, you've got a -x but a positive y. In quadrant 3, they're both negative. And in quadrant 4, you have a positive x and a negative y. So then you want to use that to figure out which of the, like based on what they're describing there, which quadrant, or quadrants, because it could be more than one, would satisfy those. And then 79 through 83, you want to use your Pythagorean identities, which again, I'm going to show you a trick in just a second. And then I would use triangles for these. So because it doesn't say, I think the triangle's easier. Set up your triangle. Tangent would be opposite hypotenuse, and you're in the second quadrant, so draw it out. Okay, so your Pythagorean identities, I'm going to show you a trick to remember them, okay? If you can remember sine squared plus cosine squared equals 1, then you can derive all the other ones from it, okay? Hopefully this is something that you just learned. You're going to use this a lot the next couple weeks. But hopefully it's something you just learned. But if you get stuck and you're confused, there's a little way to derive them. So if I remember that one, that's the first one. If I take all 3 of those spots and I divide it by cosine, so I'd get sine squared plus cosine squared equals 1. And I divide everything by cosine. Sine squared over cosine squared becomes tangent squared. Cosine squared over cosine squared becomes 1. And 1 over cosine squared is secant squared. And that's the second identity. What? I divided all of it by cosine squared. And then simplify. So sine over cosine is tangent. So sine squared over cosine squared would be tangent squared. Cosine squared over itself would be 1. And 1 over cosine squared is its reciprocal, which is secant squared. If I repeat that process, but this time divide by sine squared, go back to the original, and divide everything by sine squared, I get 1 plus cosine over sine is cotangent, so this would be cotangent squared, equals sine's reciprocal, which is cosecant squared. And that's the third. So if you can remember this one, you can derive the other two. If you can memorize all three, then you don't have to do anything. But if you don't remember, you're questioning it or whatever, if you remember that first one, then you divide them all by cosine, you get another one, you divide them all by sine, you get the other one. And the order there doesn't matter. Like, it doesn't matter if I got the 1 plus cotangent first.